Hello to our today's installation video. Today's topic is everything there is to know about the Fronius Ohmpilot. We want to talk about installation, commissioning, connection and also what types of heating rod you should connect to the Fronius Ohmpilot. First of all, what is the Fronius Ohmpilot and how does it work? It is a power regulator using the surplus energy of our PV system for our heating rods. In more detail, we have the surplus detected by our Fronius smart meter at the feed-in point. This is being sent to the Fronius inverter, and there we have the direct connection to the Fronius Ohmpilot, and we know exactly how much surplus energy we should give to our heating rods. And this is where we then have a higher own consumption because of this. Of course, there are limits. We have the Fronius Ohmpilot available for 3 kW heating rods, single-phase connection, or 3-phase connection would also allow up to 9 kW of heating rods maximum. And in total, 2 heating rods can be connected on one of our Ohmpilots. Now, when we look closely, we quickly want to go through the display, the settings, the possible settings that we can do on the display of the Fronius Ohmpilot. We have a button at the very front with 3 descriptions on it. One press of the button would open the access point or activate the access point. So if your router has also a WPS feature, you could click there as well, and we have automatic connection, automatic password cross-check, and the connection would be set up. 2 presses on this button would open the access point, which we later on need for the commissioning process, so we come back to that. And 3 presses would activate the boost feature, which is essentially a 4-hour full power usage of our heating rod that we have connected. So if we have a 9 kW heating rod, we would for 4 hours push as much energy as possible into the boiler in order to heat up the hot water as fast as possible for a maximum of 4 hours as mentioned. So this would be 3 presses on this button. Yeah, we also see 3 LEDs at the very front, indicating the basic functions, the basic processes that we have. The far left would be the production LED. The faster it blinks, the more energy we have over the Ohmpilot. The middle one is the access point or the network LED, let's call it. And the far right one would be a troubleshooting LED, let's say. So if we have a problem, we would see it directly if this LED is blinking red. All right, we have for the Fronius Ohmpilot not as high as a IP protection class as with our Fronius inverters. Therefore, it's very important to remember that this one is placed indoors, direct or in a very close distance to our boiler, which we then might want to use. There is actually also a limitation. Please make sure that the Ohmpilot is sitting no further than 5 meters away of cable distance of the actual heating rod that we want to place finally. So 5 meters maximum from here to heating rod. From here to the inverter, that's not a problem. Our maximum Modbus communication line, if set up correctly, would be 300 meters. So there is no problem there. All right, so that's everything to know about the outside of the actual Ohmpilot. Now we want to open the front hood and take a closer look in the inside of the Ohmpilot. Now with the front hood off, we can see a little bit more clearly how it looks inside. We see the actual print board, the power board in the background here with the connections on the bottom for AC input and also the output. We see the actual brain, the communication center of the Ohmpilot at the front here, and this is where I also want to start our journey now. So very prominently positioned here we see our Wi-Fi connection or Wi-Fi antenna. So this is possible to connect directly from the Ohmpilot to our network, and via network the Fronius inverter would find the Ohmpilot. The same goes for the network connection. Also here we don't want to go directly to the inverter, but to our network, and over the network connection we then find the Ohmpilot. Or the third option, and also the one that I use today in this option, in this setting here, is the Modbus communication. So with this 3-pole connection here, we have the option to use RS485 and directly connect it to the inverter. Now, of course, a cable is a cable. It's a little bit safer, and if a direct connection is possible, I also would recommend this. But just want to mention it, all the other options, the connection options, would work as well. So Wi-Fi, LAN or Modbus RS485. Now, if we use RS485, don't forget there is this set of buttons or dip switches at the top here. Can be red or some versions also blue. And you can forget about all of them, but number 5. The dip switch number 5 would symbolize our 120 ohm resistance. So in our case, this is our end component. We go directly from here with the Modbus cable to the inverter. So this is end component, and therefore we need to set the 120 ohm resistance to the top position to on. If we would have a second pair of cable in here and would go to another Fronius smart meter or to any other component, then we would need to switch this to off. This is the only scenario where we would have to switch this to off. As standard shipped, this would be always activated. All right, last but not least, we also find ourselves here with a PT1000, a temperature sensor. And this one can be equipped optionally, so you don't have to use it, but again, I can highly recommend it because it allows us a few more features, which I will show you later on in the commissioning. So this would be very standard here connected, and then we would set it within our boiler in order to measure correctly. This would actually be one of the big benefits. If you use a PT1000, you would see in SolarWeb in our monitoring the degrees Celsius that you have in your boiler. But that's just one small benefit. In the commissioning, we see later on what's else. All right, so that's for the communication compartment. Let's go a little bit further down to our contacts for AC input. This would be on our far left-hand side. Single or three phase, retrospectively to what you're using as heating rod, if it's a single or three phase heating rod. And then for the heating rod connection, we start at the very right with L1, L2 and L3. And please don't forget, only L1 is the dynamically controlled one. So if you have only one heating rod in a single phase that you want to connect, it has to be connected to this one, as this one is the regulated one. Phase 2 and 3 are simply switched on or off. There is no dynamic control. All right, and also we see here as well the neutral conductor is carried out. We hear this later on when we talk about the heating rod itself. It's very important that we have the heating rod carried out on the AC input as well as to the actual heating rod. Right, and between L1 and L2 we also have this multifunctional relay contact, which also gives you a little bit more possibilities, let's say. One would be to use up to 2 heating rods, which is possible as we have heard, and this one plays a major role in it. We see later on how. Or it would also give you the opportunity to switch on a smart grid ready heat pump, for example. And there we also use this plug. But more on that later in the commissioning. All right, so that's it for now. we have seen enough of the hardware. Now we want to focus on which heating rod we can actually use. Now, when it comes to the correct decision of which heating rod you want to use, it's very important to watch out for these next few steps. First of all, we already have heard single phase 3 kilowatt and three phase 9 kilowatts. That's important to not exceed these limits, otherwise you will get an error message or you could even destroy the Ohmpilot. Next up, it's important that we have a star topology, a star wiring. So no delta or triangular connection here. And the second very important topic is to have also the neutral conductor carried out. So here we have a star connection and we see the neutral conductor is carried out and then led to our Ohmpilot. One more example would be with this, a little bit simpler heating rod here. We see the three connections for the phases, and here would be then the connection for this star topology for the neutral conductor. Very, very important to have this. Otherwise, you again would not be able to use the Ohmpilot. So, star connection instead of triangular and carried out neutral conductor. Single or three phase we already mentioned. One more thing would be use real ohmic loads. So no active controllings or a fan. Something like this would get destroyed because we are operating with a pulse width modulation signal, and therefore every active controlling unit would get destroyed. So important to leave this out. So you already see, the simpler the heating rod, the better it is for the usage of the Ohmpilot. Last but not least, there is always a question about the bimetal sensors, the mechanical temperature sensors out here. No problem. These do not count. Also LEDs like this, that's not a problem. You simply want to set it a little bit higher for the temperature rating, as you would have the temperature rating within the Ohmpilot if you use, for example, a temperature sensor, the PT1000. So if I want my temperature to reach up to 50 degrees in the boiler, I want to set this a little higher to 55, let's say, because otherwise it would switch off first. All right, so that's everything there is to need to know about what to look out for when deciding about the heating rod, which one you want to use, you should use. And now it's time to start the actual commissioning of our Ohmpilot. And therefore we quickly close up the Ohmpilot behind me, turn on AC again, and then start the commissioning process. So for the actual commissioning process, we want to first of all go into the web interface of the Ohmpilot, do the settings there. I want to explain everything there is to know. And then we must not forget to always add the Ohmpilot as a component in the web interface of the inverter. So that's step number 2 then. In any case, we want to open now the access point of the individual component. So for the Ohmpilot, we already heard it's 2 clicks on the button, and therefore the middle LED starts blinking blue, indicating the access point is open. Now, our next step would be to use the Solar Start app or to use a laptop and connect with this Wi-Fi access point. This is what I also want to show you today. So we go to our Wi-Fi settings, we search for Ohmpilot underscore and the serial number. This is the access point of our Ohmpilot, and we want to connect with it. Now, after a successful connection, we want to open our browser. If possible, use Google Chrome. We have the best results there. And then we want to type in the standard IP address. Every time the same thing for Ohmpilot and every Fronius inverter. Now with this IP address, we directly come to the web interface of the Ohmpilot. What we see here is the main overview with 3 status indications. So status, temperature and heating output. We currently have a status because we haven't set it up correctly. There is no connection between the, or there is no component added on the inverter. Therefore, we have a communication error. The temperature is visualized to us because we have a PT1000 set up, and there is no heating output because we have no heating rod connected in our case. Now, further down below, there is a list of some interesting informations, such as the pairing. So after we have done it correctly, we should read here on pairing the serial number of our inverter. So if done correctly, this should be set up here. Now, this is the first screen. The second screen is the more interesting one, and it's on the submenu General. So if we go there, we have all the settings, and I quickly set it to standard. So this is what you have when you first connect to a brand new Ohmpilot. You have designation, you can rename it if you want, and you have the heater number 1 on automatic. Single phase is automatically selected here, and it's automatically searching for the maximum watt, for the maximum power you can use this single phase heater. So you can do it manually as well. You can then measure the heating element manually, or you can also exchange here from single to three phase if necessary. This measuring, very important to know, is done every time we have an AC reset. So every time we have a grid outage, for example, and we turn back on the Ohmpilot as well, we have this measurement. And this is very critical because in a backup system, we would have the full power of this heating rod drawn for this short measurement. And if we have the wrong sizing or a too big of a heating rod, it could turn off permanently our backup solution. So if possible, please make sure that the Ohmpilot with its heating rod connected is outside of the backup system in order to prevent this. Remember, every time AC is reconnected, Ohmpilot starts to read the power of this heating element. Now, in my case, I leave it on single phase and automatic. That's perfectly fine for me. And in our case, I already mentioned, we have a temperature sensor. And if we have one, we have multiple additions. So I select here, sensor is present. And then we have one of the most useful features, which is called maximum temperature. So this is where I can set a maximum of, let's say, 60 degrees Celsius that I want to have in my boiler, done by my Ohmpilot. So if we reach this, the Ohmpilot turns off production. The second option that comes with a temperature sensor present is a Legionella prevention. And if I activate this, I can set an hour or a period in hours in which the Ohmpilot is heating up the whole boiler above a certain threshold in order to kill all the Legionella. So it's a safety precaution, you could say. And you can set this, for example, to every 200 hours I want to do this, to heat up to above 60, 65 degrees Celsius in order to prevent Legionella. So this option also comes with a temperature sensor. And the last thing possible is to adapt a day curve. Now watch, if I click this one, it opens up a time schedule with from which time to which time you want to have which minimum temperature. Let's say from 5 to 6 p.m. I want to have 15 degrees Celsius temperature. Then the Ohmpilot knows, okay, from 5 o'clock I need to start heating up from the sun, or if not available, also from the grid. But I have to set a minimum of 50 degrees Celsius. So it's a very convenient feature if you want to leave out your primary heating system at all during summertime and really just rely on your Ohmpilot. Then you can set this, for example, also a second one for, okay, from 6 o'clock to 7 o'clock I want a minimum of 40 degrees. In all these times, the Ohmpilot is responsible for this minimum temperature. But, and this is the most important thing to also tell your customer, in this time, the Ohmpilot also draws from the grid. So this can cost you, of course, as well. So very important feature, and very important to remember to tell the customer, as soon as you set anything here on the adapt day curve, the Ohmpilot will not only use surplus energy but also energy out of the grid. Same goes for the Legionella prevention. Also here we draw from the grid every 200 hours. All right. Now, last but not least, we have a heater 2 option. So we already know, we already mentioned, 2 heating rods can be connected in maximum on such an Ohmpilot. And this one can be a single phase or a 3-phase as well. Very simple, you select here and select the wattage and also can measure it through here. Or there is some more features you can use the heater 2 for. For example, the SG Ready heat pump. Now, SG Ready stands for Smart Grid and allows you to communicate. It's just a 2-pole cable that you connect from the Ohmpilot to your Smart Grid Ready heat pump in order to tell the heat pump, if we have 4 kilowatt of feed-in power, please turn on a higher production, a higher temperature. And if we have 0 watt consumption or feed-in, whatever, please turn off this feature. So the idea behind it is that we want to tell the heat pump exactly, okay, now you have enough power from the sun so that you can heat up more hot water. So if there is not enough surplus power, it only heats up to, let's say, 40 degrees. And if this signal is set, if the signal comes from the Ohmpilot to the heat pump, it knows, okay, now I can heat up to 60 degrees, for example. And of course, this also gives us the benefit for a little bit better efficiency. We all know with a heat pump we have up to 4 to 4.5 efficiency rating, so we get more hot water out of the same amount of electrical energy. So why not make use of that in the best way that is possible with a connection pole? Very simple. And I haven't mentioned that the connection that I was talking about, the 2-pole cable, this is connected on our multifunctional relay that we have seen earlier. So for that matter, I can highly recommend to check out a sketch that we have in our manual. For example, here would be an application example with 2 heating rods. One heating rod is a single phase connected in our boiler. The second one is 3-phase connected in our puffer tank, for example. Very simple, or it could also be in the same boiler, doesn't matter. Now, both of these can be dynamically controlled, but we must not forget one important thing. One outlet, the first phase, is dynamically controlled. So we need to make sure that this one is bridged onto our multifunctional relay. And from this multifunctional relay, we then go from normally closed to heating rod number 1. And from the normally open, we go down to heating rod number 2. And by this measure, we make sure that both can be dynamically controlled. Very, very simple and effective. I don't need an external relay for that. I can make use of this multifunctional one. Now, in this manual, we also have other examples like we see here with the Smart Grid Ready. So here I can explain a little bit better what we have just seen now in the Ohmpilot menu. We have a single phase heating rod connected in the boiler, and the multifunctional relay is being used for the control of this Smart Grid Ready heat pump. And the signal only switches to on when we reach a certain threshold, like we have seen 4 kilowatt or whatever, however big the heat pump is actually. And the main benefit now, I quickly switch back to our overview. The main benefit why we want to connect a Smart Grid Ready and a heating rod in one system with the Ohmpilot is that up to this threshold where we want to switch on the Smart Grid Ready heat pump, we use this surplus power, as mentioned before, dynamically with our single phase connected heating rod. So both options or both benefits at the same time. Up to the 4 kilowatt, we use single phase dynamically controlled, and from 4 kilowatt and above, we use the highest efficiency with our Smart Grid Ready heat pump. So this is again also one way how to use the multifunctional relay within our Ohmpilot. And last but not least, we also have something called Activate External Source. Now watch, if I click this, it automatically opens the Adapt Day Curve. And the reason for that is that within our time slots here, the Ohmpilot is not longer responsible for this temperature, but our external heating sources. So for example, we have an oil oven, a gas oven, a pellets oven, whatever our primary heating source is. We can now control this one, again with our multifunctional relay, and say, the Ohmpilot now has the control and says, okay, between 5 and 6 p.m. or 6 and 7 a.m. you need to watch out for these minimum temperatures and give us this minimum temperature. And the Ohmpilot is doing what it can do best, only using the surplus power. Now, of course, in order for this to work, you need to make sure, first of all, that your primary heating source has this kind of connection possibility. Only then you can use that. All right, so this is the last feature I want to quickly mention as option here on heater number 2. Okay, and last but not least, if you do any changes, please not forget to click the Save button and then you can proceed. In my case, I don't have anything connected here, I leave it. And I want to show you, last but not least, the network settings on the Ohmpilot. And on the network setting, you only need to do something if you have, as mentioned before, not an RS485 connection. So in my case, I have RS485 directly to the Fronius inverter. I don't need to go in there. However, if LAN or Wi-Fi is connected on your end, then you want to go in here. On Wi-Fi, you see all the available networks. You select the one that your customer network is and connect with it. And for LAN, the same thing. You can also change here from static to dynamic IP address, for example, and connect. And after that, as mentioned before, the Fronius inverter automatically finds the Ohmpilot if it is in the same network. That's the only permission we have. All right, so that's it for the Ohmpilot settings. Don't forget, hit save when you are ready. And last but not least, we must not forget to also set the component within the web interface of the inverter. And this is what we want to do now. In order to do that, we also want to open the access point here. Again, with a simple click on the middle light sensory button, the LED starts blinking blue, indicating the access point is open. Now, again, you can use Solar Start now for the actual connection, or like me here, we can also use the laptop. In the Wi-Fi settings, we search for Fronius underline and then the serial number of the inverter. And if you found it, you click on Connect. And if it's the first time, remember you also need a password. Therefore, it is again written on the side of the inverter on the nameplate. Or if it is an old inverter, there is the standard password with the numbers from 1 to 8. After a successful connection, we come back to our Google Chrome browser and we type in the same exact IP address as beforehand with the Ohmpilot, and we come to our interface of the actual inverter. Now, the first thing I want to do is I want to log in as technician. After we have done that, we can go on the left-hand side to device configuration and then components. And in here, like every component else, we want to add it. There is also Ohmpilot listed because we have found it over the network or via the Modbus communication. And therefore, we can also select it. We can here select which Ohmpilot it is. If we have multiples in my network, we can decide which one I want to pair with this inverter, and I want to click Add. Please do not forget or mistake this information. Only one Ohmpilot is possible to use per feed-in point. So not multiple can be used. All right, and after we have done the connection, don't forget, click the Save button. And if everything worked, it looks like this. We have a green LED on the left-hand side. Currently, it still needs to do the pairing. Now it's green. We know, okay, this is working. And yeah, it would be ready to use right now. So that's everything you need to do. Go to the components, add the component Ohmpilot and pair it with this inverter. That's it. Now it does work. All the rest of the settings are being done separately on the actual interface of the Ohmpilot, like we have seen previously. Now there is one more feature I quickly want to show to you, and this is by going back one slot to energy management and load management. Within here we can set priorities. For example, we can say which one comes first. Do we want the stationary battery to charge first and then the Ohmpilot, or the other way around? Or the third option would be the load management, our digital in and outputs on the pilot print of the inverter. Do we want them to switch first and then the rest with Ohmpilot and battery? So very simple, drag and drop, and if it's finished, don't forget, click the Save button. All right, so that's it for the installation and commissioning. I now wish you all the luck for your installations.